In my previous video, I designed this tied square column based on this data. So this time I will design this column for spiral reinforcement. So this will be a spiral column, and I will make it circular, and this value will increase. Let me see what is the value in your book. So this is 0.75. So what I will do, based on this data, I will design a spiral circular column, and my factors as this. Okay, so step number one is calculate load. 1.2D plus 1.6 L, 130 kib plus 1.6 L, 180 kib. Total is 444 kib. Step number 2, choose a rho G. If as my rho G is given, I will not choose. If it was not given, I would choose 2%, 3% like this. So step number 3, calculate AG. How to calculate? My equation is PU P alpha AG minus rho G AG 0.85 F prime C plus rho G AG Fy. So from this equation I will calculate AG. So this value is 404 kb equals 0.85, 0.75. AZ I do not know. Rho Z is 0.02, 0.85 for KSI plus 0.02. AZ I do not know. 60 KSI. Something to see here is that as this value is in kib, this should be in KSI or KSI. Okay, so if I solve it, it might be tough. Okay, I'm doing very quickly. If I make any calculation mistake, okay, then divided by 0.98.85 times 4 is 0.02, 60. I got 154. After solving, I am getting 154 inch square. This is kib, this is KSI, so it will be inch square. Now I did it very quickly, so if there is any calculation mistake, you can revise. So okay, so I got my gross area required. Then I will select in step number 4. I will select a size. So my problem says circular. So let us see what is my size required. So pi d square over 4 equals 154. Then what is my d? So my d will be times 4 divided by 3.1416. 13.99 inch is my diameter. So I will is almost like 14 inch diameter. 14 inch diameter. Okay. So in my next step, what I will do, we will revise our reinforcement. So I do not need Okay, still though, keep it. Step number 5, calculate AST. Now, something to see. If whatever needed and whatever provided is exactly same, we can skip. We can simply use this equation. If my provided AZ and whatever needed and whatever provided, whatever provided, exactly same, we can simply use this equation. So this time we are providing exactly the same thing. 154 times 0.02, 3.08. Now, if it is not same, then what we'll do? We will use the other equation. In my previous video, I showed other equation, that is this equation. So in this equation, if I use 4, 4, 4, this is 8, 5, this is 0.75, gross area is 154, AST, 0.8 prime C, AST 60. Now if we use this equation, you will get this reinforcement, the same reinforcement. So if whatever area required and whatever provided is like equal, then this equation or simply this equation will give you the same answer. If you provide more, then you have to use this equation to get a more accurate number. Okay, so step number 5 is done. Then we will choose a bar. So 3.08. 3.08, if I go to table appendix A4, 3.04, and for spiral circular we need minimum 6 bar. Okay, 6 bar, 3.04 is 6 number 7. Yes, 6 number 7 should be, or 7 number 6. Yes, so step number 6. So 6 number 7 or 7 number 6, both are good here. Okay, so in our next step, what we will do? Next step, we say we are choosing this one. Next step, we have to design the spiral. Say number 7. What is the step? So which spiral we will use? We will use number 3. Why number 3? Our main reinforcement is number 7. Up to number 10, we will use number 3. Then what is the spacing? You know that spacing equation is this. Where AS is 0.45, AZ minus A core minus 1, A prime C, FY. Okay, so let us find one by one. What is, we know our gross area. Okay, first calculate this one. 0.45, gross area was 154 inch square. What is the core area? Core area is whatever the reinforcement after placing reinforcement and spiral, the outside area. So if we provide 1.5 inch both side clear cover, if we provide 1.5 inch clear cover, then our DC core diameter will be 14 minus 1.5 minus 1.5. Why 2 minus 1.5 here, 1.5 there? Then this portion will be outer to outer will be our DC. So DC is the out to out spiral. That means outside spiral, outside spiral. So deduct only the clear cover. That is 1.5 inch, 1.5 inch. That means my DC will be 11 inch. Okay, so pi dc over 4. This is 95. Again, how I got it? How I got A4? It is pi dc square by 4. Okay, minus 1, 460. So 154 divided by 95 minus 1 times 4 divided by 60 times 4.5. I got 0.0186. Okay, so insert here. Then what is my spacing? So 4.11. Area of number 3 is 0.11. DC I found 11 inch minus dB, diameter of the bulb is 3/8 divided by 0.0186 times 11 square. What is the spacing? Okay, 4 times 0.11 times 11 minus 3/8 divided by 0.0186 divided by 11 square. I got 2.07 or 8 inch. Now what is the minimum possible? Minimum possible is 1 inch. What is the maximum possible? Maximum possible is 3 inch. So my value is in between. So it's good. But we will not provide 2.08. We will provide 2 inch, 1 center. We can provide less spacing, not more spacing. So spiral design is done. We choose number 3. Why number 3? Our main reinforcement is number 7. This is why. And then we calculated the spiral ratio, then spacing required, and matched with the minimum and maximum. Okay. So next step is detailing. Detailing. So take a big picture. 6. So right here 6, number 7. So right here number 3 at the rate of 2 inch 1 center, and then show that it is 4 inch dia, and show somewhere here to here 1.5 inch clear cover. And then something else too, we have to check the minimum spacing. The minimum spacing for any reinforcement, you know from your previous beam design, is 1 inch or bar diameter. So ideally we should check that also. Okay. Okay, let us check very quickly. What is the clear spacing? Clear spacing, how to find it? Okay, so we need this center to center distance. This center to center distance is, what is the center to center distance? That will be like, okay, 14 inch minus 1.5 minus 1.5. Then we are deducting the clear only. Then we will minus the spiral. So spiral is 3/8, 3/8 here and here. Then we will deduct half of the bar. So half of the bar is 7, or half of the bar. So minus half here, half there. Total is 1. Okay. So that is the dia. This center to center dia. Okay. So 17 minus 3 minus 3/8 minus 3/8 minus 7/8. So that is 9.375 inch is my diameter. Now let us see what is this distance. This distance is perimeter. So pi d. So pi d will be, that is 29.45 inch. So pi d is this. Now inside this, how many bar? 1, 2, 3, 4, 5, 6 bar. So 29.45 minus 6 bar, their die is 7/8. Then how many space? 1, 2, 3, 4, 5, 6. 6 space. So this will give me the clear spacing between bar. Okay, so minus 6 times 7 divided by 4, or something wrong, 9.45 minus 6 times 7 divided by 8 divided by 6. I got 4 inch. 4 inch clearly. So my clear spacing between two bars 4 inch. This is greater than 1 inch or bar diameter. So it is okay. It is okay. Number of bar 6. So 6. So 6 is okay. Size 14 is good number. So overall, like, you have to check all this. So hopefully you understood how to design a spiral column. Nothing scary. Just follow all the steps. Thank you.